Hi class, today we're going to work on solving quadratic equations by factoring. So in the past you've had the opportunity to solve quadratic equations by graphing, where we had to graph the function and observe where the zeros are or the x-intercepts, okay? So that's what it means to solve for quadratic equations. Now today we're working on solving by factoring. Okay, so if you recall, we practiced a little bit on factoring just to refresh your memory. And so today we're going to start with what you call the zero product property. Now, this is a very special property which you will be using for your other topics, where it says that if the products of two quantities are being multiplied, okay, and it will result in at least in a zero, then at least one of the quantities is actually equal to zero. So think about this. For example, if I were to multiply a and b together and it's set equal to zero, then that means that one of them, okay, should be equal to zero. In the same manner, if I multiplied 3, the only value that I would multiply a 3 or a 4 with to get a 0 is 0. So meaning one of the two values must be a 0, all right? So we're going to use that context right now to work on solving by factoring. All right, so we are instructed to use the zero product property to solve the given equation, and we're going to check the answer at the end. So basically what it does is, now that you have the factored form of the quadratic equation like so, you have your two binomials. It says that if the two being multiplied together, okay, this will be your A, this will be your B. If they're being multiplied together and if that's equal to 0, right, then one of them must be equal to 0, or at least one of them. So what we're going to do is we're going to set each of those factors equal to 0, like so, while the other one is also equal to 0. Okay, notice how we're doing two things right now. Okay, so let's finish the left side first. X minus 3 when set to 0 gives you a value of x, which is 3. All right, you want that. You want to solve for x. On the other hand, x will become a negative 7. So we say that the zeros of the given quadratic equation are 3 and negative 7. All right, and that's it. So this is how we solve by factoring using the zero product property. That's all it says. Set each of the factors to 0 and solve for x. All right, so how do you check? Here's what you can do to check. If you were to plug in each of the values that you found, if x equals 3, let's start with 3. If you plugged in 3 for x, it would say 3 minus 3 multiplied by 3 plus 7 should equal to 0. Okay, so go ahead and simplify. This is a 0 multiplied by 10. Will it equal a 0? Well, if so, then you did it correctly. On the other hand, if you did x equal to negative 7, let's plug it in and see if it works. What's negative 7 minus 3 and then multiplied by negative 7 plus 7? Will that equal to 0? Let's see. All right, so this one's negative 10 multiplied by 0. Is that equal to 0? Then yes. Then those are both answers to the problem. Okay, so let's take a look at the next example. We're also solving by using the zero product property, where this time notice that the two factors are the following. You have an x and an x minus 5. So each of them is a factor. Okay, so originally your problem would have looked like this. X squared minus 5x equals 0. And then because you're factoring, you're finding common factors, or if it's a trinomial or a binomial, you're going to factor it accordingly. So right now you factored out the x, that's why we produced the given. So let's set each of the factors equal to 0. Well, the first one is x equals 0, nothing to solve there, that's done. On the other hand, you have an x minus 5 equal to 0, where x will become positive 5. So the zeros of this problem are 0 and positive 5. Okay, so notice how I'm writing the answers just like 0, 5. That's it. Do not put it in a parentheses. If you do that, if you do this, 0, 5, that means there's a point on your graph which is found on the y-intercept. Is that an x-intercept? No. That's why we don't put it in a coordinate form unless for those of you who would rather say the zeros are found at 0, 0 and at 5, 0, then that's fine. This is fine. Okay? but please do not combine them. All right, let's go forward. So right now I have two examples that you can try out. Go ahead and pause the video at this time and give yourself a chance to answer the questions. All right, here we are. In the first one, you have two factors. You set each of the factors equal to 0, like so. Okay, nothing to do on the left side. It's already set to 0. X is 0. On the other hand, you simplify it further. And so we end up finding that the zeros are at 0, -4. Similarly, in the second example, you set each of the factors equal to 0, like so. All right, and then we simplify further where we find that x will be equal to -4 and 3. So we say that the zeros are at -4 or 3. All right, and that's okay because if we remember, quadratic equations will either have no real solutions or one or two of them. In this case, we're finding that there's two of them. All right, let's go forward. All right, so in the next part, we're actually going to be factoring. But let's recall, when we're worked on factoring trinomials, all right, or any polynomial, we always want to make sure that the equation is in standard form. Okay, so let's review. What does it mean to be, for an equation to be in standard form? It just means that your degree, the degrees of each term, should be listed from the highest degree to the lowest. Okay, so for example, in part A, it says x squared plus 7x, where the exponent is 1. And on the last one, you have 10. There should be an x, but it's raised to 0, so we don't write it down anymore. Okay, so from here, we're going to go ahead and review factoring so that we can find the zeros and solve for the quadratic equation. All right, so if we remember, we're going to look at 10 and think of factors of 10 that will add up to 7. All right, so on your mind right now, the factors of 10 that add to 7 are 5 and 2, like so. So we're writing it out just like as normal factors. And from this point, you use your zero product property to set each of the factors equal to 0. Once we do that, we're going to solve for x. The first one, x will be -5. On the second one, x will be -2. And therefore, the zeros of the given equation are found at -2 and at -5. Okay, and then you can always check, plug in the values one at a time, and check if it is going to set equal to 0. On the other hand, let's look at the next example. Okay, so with this example, we are supposed to rearrange it first and make sure it's in standard form. So notice how the x squared is on the left side. Okay, so you want to, here's my tip. You want to move all the terms wherever the x term is. Okay, so let's move 8 over. Let's write what you call a related function, where this is equal to 0. Okay, that's all it is. Rewrite it so it's in standard form. Now that it is, let's move on to factoring. What are factors of 8 that will add to +2, right? Okay, so right now we're thinking of factors of 8. Okay, 4 and 2. Will 4 and 2 give you a 2? Yes, it will, but you need to check the signs to make sure you're very careful with this. You want to have a +2 result as a sum, but the product needs to be negative. So let's place +4 and -2. So that the product is -8, but the sum will be +2. And now we set each of them equal to 0 using the zero product property, where we find that x will be -4 or +2. And these are the zeros of your given equation. All right, they're super cool, but it really helps to remember how to factor. Okay, so let's go forward. Okay, so right now we have a couple more practice materials. Let's look at part C. All right, check. Is our equation in standard form? Yes, it is. Let's find factors of 1 that will add to 2. All right. Okay, yep, you're right. It's a 1 and a 1, like so. And it's okay because if you remember, this is what you will call your perfect square trinomial, where you can get the square root or the first and last terms are perfect squares, like so. If that happens, notice that we're going to use the zero product property once again, but they're exactly the same thing. So you don't necessarily have to do this twice, especially if it's a perfect square trinomial, okay? All right, so in this case, really, The 0, there is only one 0, and it's found on -1. All right, super cool. All right, so next one. Remember when we said we need to rewrite in standard form? And my tip was to move all the terms wherever the x squared term is, wherever the highest degree is. Okay, so let's move everything to the other side. So I'll set it up as -2x squared. Standard form, so I need everything to be in order, right? Positive 12x and -18. Now it's equal to 0. All right, let's look at the given trinomial. Okay, so you always want to ask yourself, okay, is there something common among all the terms? If so, then you must factor it out. In this case, notice how the leading coefficient is negative. Remember when we had to review factoring out negatives? We really want to do that right now. Okay, so not only is a negative factor supposed to be taken out, all of the terms, if you notice, are divisible by 2. So let's actually factor out -2, like so. If we do, we result in x squared minus 6x, right? Okay, continuing, plus, okay, changing the signs, 9. All right, like so. And so what that does is now we're just going to be factoring the trinomial right here. Okay, copy -2. We don't need to change anything there. All right, what are factors of 9? That will add to 6. In this case, we want a -6. Okay. All right, factors of 9, you said, are 3 and 3, but because we're expecting a -6, we're going to make both of the factors negatives. And similarly, observe how the factors are the same. So we're saying this is actually also a perfect square trinomial. Okay, once you've factored out the -2, yep. All right, so let's go ahead and solve. Again, because it's the same, you don't need to repeat it or write it twice. So we're going to set that factor equal to 0, and really, this 1 0 you're finding is found at +3. Okay, so again, you can check. You can plug the value back in and see if it is a true statement. Or again, you can also check with graphing, since that's a tool or a process that you already know to use. Okay, all right, so on the next page, you'll have an opportunity to practice and try out 2 problems. Go ahead and pause the video at this time and give yourself the opportunity to try this out. Okay, let me go ahead and check the first one with you. All right, so check, is my equation in standard form? Yes, it is. Let's go ahead and take a look. Because it's already in standard form, I know factors of 9 that add to 6 that are negative, or -3 and -3. Because it's very much like what we did previously, it's actually a perfect square trinomial. We're going to set each of the factors equal to 0. And so solving for x, which is 1 and the same, will be at +3. All right, good job. On the next one, notice how our equation is not in standard form, so let's set it up. Let's rearrange this. My tip was to move every single term wherever the x squared term is. So let's see. All right, so this is the related function. Okay, now check, is there something divisible by all the terms? No, there isn't. However, because the leading coefficient is negative, we must factor that out. All right, so let's take a look. We've factored it out, okay, like so. And because our leading coefficient is not 1, we can't just normally factor the given trinomial like what we did with the previous one. Instead, you need to do your slip and slide. Okay, you guys remember this, yes? All right, slip and slide, meaning you're going to slide number 9, the leading coefficient, and multiply it by 25. So that the leading coefficient, is going to be a 1. All right, and then 9 multiplied by 25, 225. And so from here, you can start factoring like a normal trinomial, where the factors of 225 that add to 30 are actually 15, like so. However, remember that you did the slip and slide. And what that does is you always need to remember and take this extra step. Because you moved a factor or a value, you need to divide 15, the factors you found, by that number that you slid or that you moved. All right, notice how I'm dividing each of the values by 9. All right, you must make sure to do this, otherwise it changes your whole answer. And you want to simplify this. In this case, it's 5/3. Okay, and once again, it's a perfect square trinomial. That's why your factors are the same. All right, so let's rewrite them in their factors like so. X plus 5/3, yes? All right. However, if you remember, there should be no denominator, so we don't want to see fractions because there are no fractions in our equation. So we're going to rearrange the given factors. So it will become a 3x plus 5 and another 3x plus 5. You guys remember this, yes? All right. And so because, again, your factors are the same, you don't need to solve it twice. You take that 3x plus 5, set it to 0, and solve for x. In this case, we're getting that x is actually at negative 5/3. And that's okay. Sometimes your parabola will not intersect at a specific point. Sometimes it's in between, and that's absolutely fine. Okay? All right, so hopefully you were able to try this example out. I'll bring you to the application. All right, so this time we're looking at an application right here where you have the height of a diver above the water, as you can see, where the given equation models the movement. H is the height in feet, and t is the time in seconds. We're going to find the time it takes for this diver to reach the water. So essentially, how long is the person in the air? So that question and how long does it take to reach this point mean the same thing. So we're solving for the x-intercepts. So imagine that this right here is actually an x and y. Oops, I cannot draw a straight line. Imagine that this is your x and y axis. This is your x-axis right here. This is your y-axis. Okay, so that's what we're trying to do here. All right, so let's apply what we learned from the factoring problem. Okay, so observe your trinomial right here. We're going to set it first equal to 0 because we need its related equation, like so. All right, so check. Is there a value divisible by all three terms? All right, that's the first thing you check. The second thing, oh wait, there's a negative. I should take that out because Mrs. Flores highly recommends it. All right, so you've found that it is in fact divisible by 8. So not only am I taking out the negative, I am dividing each of the terms by 8. All right, let's do that right now. So you end up with a 2t squared minus t. Notice how we're changing signs, minus 6. All right, so just like so. From here, you have a trinomial that you can factor out. But hold on, the leading coefficient is 2. All right, you need to do something about that. So at this point, negative 8 stays there. There's nothing to set it equal to, so let's leave it by itself for now. However, in our trinomial, we're going to do your slip and slide, where you're multiplying 2 by negative 6. All right. And so now we proceed to factoring your trinomial. What are factors of 12 that will add up to negative 1? Okay, so you're thinking of 1 and 12, 2 and 6, 3 and 4, all right, and your only options are 3 and 4. However, because it needs to be a negative 1, 4 will be negative, and 3 will be positive. All right, so from this point, are we solving yet? Does that mean the t values are 4 and negative 3? No, because we're not yet done. Remember, because you did the slip and slide method, you have to remember to divide each of these terms by the number that you move. Okay, it's really important that you do that. So let's rewrite it over here. So my factors are going to be negative 8, where the simplified form of 4 over 2 will be 2, so t minus 2, like so, where the next one cannot be simplified further, however, needs to be rearranged into 2t plus 3. All right, so I think we're ready to solve. Let's set each of the zeros, or the products, set to 0, like so. All right, where the left side, we find that t is equal to 2. On the other hand, 2t will be equal to negative 3, and t is negative 3/2. All right, so going back to the question, we've found our zeros. Now, we're going to find the time it takes for the diver to reach the water. Okay, so let's say the diver gets into the water at this point. So time must be positive. Therefore, we cannot use the negative 3/2. So we say it takes the diver 2 seconds, because it's in seconds, 2 seconds to reach the water. And that's your final answer. All right, so that's how you can use the zeros of the quadratic equations. On the next page, you're going to have an opportunity to try out a similar problem. Let's go ahead. All right, what if the equation for the height above the water for another diver can be modeled by the given? Find the time it takes for this diver to reach the water. All right, so now go ahead and pause the video at this point. Give yourself some time to try this out. All right, so we're ready. Let's take a look. So we've set up our equation. Okay, so what we did was this. We noticed that among all the terms, they're all divisible by 8. But not only that, the leading coefficient is a negative value. That's why we took out a negative value, like so. From this point, we had to rearrange our trinomial by using the slip and slide method, where we multiplied -3 by 2. And now that we've done that, we can factor out the trinomial easily. We found that the factors are -3 and +2. However, because we use the slip and slide method, we need to make sure we divide each of these by the number or the value that you moved, which is 2. So notice how we're dividing each of those factors by 2. We're going to simplify them. -3/2 cannot be simplified further. However, it can be rearranged to become 2t minus 3. On the other hand, we simplified 2 over 2 with a +1. And so at this point, you have your two factors, and we're going to apply the zero product property to solve for the t values that will represent the time. Let's go ahead and take a look at the next part. All right, so we've set each of the factors equal to 0, like so, and we're going to continue solving for them, all right, where we found that the two t values are -1 and +3/2, or 1.5 seconds. So question is, we're looking for time. So then, based on these two possible answers, the only reasonable value to answer would be to say it takes 1.5 seconds. All right, so this is a really great application of your factoring problem, or solving equations by factoring. All right, so if you have any further questions, list them down, and then we'll address them on our next meeting. Okay, all right, I'll see you really soon. Bye for now.